In this video, we're going to review how to commission idling devices over EtherCAT in CODESYS version 3. And before I jump into my computer screen and what I'm going to show you on my computer today, I wanted to show you the actual hardware. So what we have today is we have this is a CODESYS PLC. And so in this case, this is only my PLC. As you can see, it's not connected on the backplane. It's not connected to my remote I/O in this case. So this is going to be my CODESYS PLC. This is the CPX-E-CEC. And then this orange cable right here is connected to, this is the CPX-E platform, which allows me to have multiple I/O cards, remote I/O cards, right? So in this case, I have analog cards. These two are analog, but this one here, the third one, is an idling master, and I have 4 channels here. So 1, 2, 3, and 4. So the intention is that I'm controlling this vacuum generator. So this is an IO-Link device. This is the OBEM. This is a vacuum generator that has some parameters, and what I want to do is I actually want to change these parameters, or at least one of these parameters. So I want to read and also write parameters to the device. Again, the topology here is I have my PLC right here. This is my CODESYS PLC connected with this blue cable. This is connected to my computer. Then this orange cable, it's actually a small orange cable, short orange cable. This orange cable is an EtherCAT cable that is going from the PLC to the remote I/O platform here. And then this cable over here is just going to the IO-Link device, in this case, the OBEM. So now let's take a look at how it is going to look like on the CODESYS environment. You can download this application note from the Festo website and follow some of the instructions there. But today I want to show you what you have to do on the CODESYS side. So I recommend having this open, this application note that I just showed you, and then of course the user manual for the device that you're going to be parameterizing. In my case, I have these vacuum generator operating instructions open for the OBEM. Okay, so now if we go to the CODESYS platform, what do I need to do? Well, this is a brand new project, and the first thing that I gotta do is establish communications. So I'm gonna go here. I already have a gateway selected. This is configured as local host. So if I'm in the same network range, it's going to automatically detect my device by you can either double click on the gateway, or you can click on scan network here, and then it'll scan for the device, and then you can click on the device and then set it as active path for this project, or you can just double click on it and it'll be set as the active path. Okay, so now we have communication to the device. That's good. Remember, that's through that blue Ethernet cable coming back to my computer from the CPX-E-CEC. The next step is here on the CPX-E system. I can double click on that, and I'm going to check the actual configuration. So I'm going to scan it, and then it says, okay, I already scanned the CPX-E platform, and I see that you only have this module, which is the head module or the PLC, right? So why is because this is not connected on the backplane, right? So if I had more modules connected here in the backplane to the PLC, then all of those modules would appear on CODESYS. But in this case, this is only the PLC, and it's not connected through the backplane to anything else. Okay, so that's good. Now we were able to scan the PLC. The next step is we have this PLC is an EtherCAT Master, so I can double click on the EtherCAT Master, and I'm going to set which oh, sorry. Let me bring this window over here. I'm going to check which network adapter is going to be used for EtherCAT communications, and it's right here. This is the name ECAT for this PLC. So I'm going to double click on that, and that MAC ID is copied in here. And that's about it for now. In terms of configuration of the EtherCAT master. You also notice here this particular PLC, it's also a Profinet device, but we're not going to use that today. Now, once that's set, what I can do is I can actually log in here, download this blank project, and then just to make sure that I have communication. Okay, stop, and I run it, and it's good. So now let me log out. And now what we can do is I can right click in here and I can select scan for devices. So as soon as I select scan for devices, it's going to immediately recognize all of the other modules that are connected over EtherCAT with this orange cable, right? So you can see the very first module is this one, CPXE EC. So it's the bus node. This is the EtherCAT module. And then the next module is an analog module, this one right here. And then this is another analog module. And then we have the IO-Link module, right? This one right here. Perfect. So that's good. Now, what we want to do from here, and before I forget pointing this out, this module is analog inputs, this is analog outputs. We're not going to use this today, but just for you to know. So the next step here is going to be to copy these modules to the project. As soon as I click copy to project right here, you'll see that they're going to be brought into the project tree under the master, EtherCAT master. So copy to project. And hold on, what's going on here? Oh, I just selected one module. Hold on. Scan for devices and select the whole thing, copy to project. There we go. Yeah, I just selected the IO-Link module. But anyways, you select from the top and then you'll get all of the modules copied. Perfect. So now if we want to check EtherCAT communications, what we can do is we can just log in again, download this application, and let's see what's happening. F5. All right, so this is running and this is giving me an error right now. Why? It's setting no driver found, configuration error. Let's see why. Why is it giving us that error? Because I did not apply. So you remember when I double click on this guy, I double click on this guy and then I clicked scan and then this appeared here. I completely forgot to click apply. So right now, the reason why this is red here, it's because it's telling me, hey, there's a mismatch in what you scanned and what you have in the project. So if I want to correct this, what I have to do is, okay, I already scanned, so now I'm going to apply this. As soon as I apply, this module is going to appear here. You'll see it. You'll see it right now. Apply, and there it is. The module is now there. So let's do it again. Let's download and make sure that that ugly red mark goes away. So it's in stop right now, so let's run it, start. Awesome, everything is green with the exception of the Profinet device, but we're not using that today, so it doesn't matter. Alrighty, so I want you to check something out. Right now, this is in run, right? And it is running. However, if I go here, you'll see that right now, this LED is on, right? So let me do something actually. I'm going to download the boot application. So create boot application, online boot application, and then I'm going to do a power cycle. So boot application was created and then log out, and I'm going to do a power cycle. So there, I lost power, and let me reestablish power. And let's see if this LED comes back on, this one right here. We're still waiting for the EtherCAT to come online. There it is. You see now this LED, the X0, didn't come on. This LED is telling us if the IO-Link port is running right now. The reason why it was on before is because I was already doing some tests earlier today and several days ago, so I already had it enabled. But this project, what you're going to see is, as soon as you start it, you're going to see that this is going to be off, disabled. Why? Is because we haven't enabled any of the IO-Link ports. All of these modules all of these ports are disabled at the moment. Okay, and I'm going to show you how to enable that. Okay, so let's take a look. If we can actually close this, we can close this, but we go to here to the main module, and then for the EtherCAT slave, and then we go to startup parameters. Under startup parameters, you are going to click add right here, and then you're going to look for this one for IOLink settings right here, and it's the 230316. Okay, so open that up, and then actually, let me see. Hold on. No, it's that one. I'm sorry, it's module parameters. Yeah, it's module parameters. Again, it's 2003 zeros. Open that up and then go to the one that's called configuration port 1 operating mode. You can see right now the value is set inactive, right? So now I can change this value to be IO-Link. So that's why those LEDs are off, because all of the ports are switched off. It's not operating in any, they are inactive, right? Same thing if I go to port 2 and port 3 and port 4, inactive all of them. So I want to change this one to active. Oh, sorry, active. And then click OK. So what this is going to do is it's telling the system that every time that it starts up, so when it starts up, we want the the port 1 to switch its operating mode to IO-Link. So let's save this and then let's log in and let's download this project, and let's see, it's in stop right now, the PLC. I'm going to start it. And now you see, as soon as I start the PLC, now this LED is on, right? Meaning that the IO-Link, the port is running in IO-Link mode now. Awesome. That's what we wanted to have now. Okay. The next step here is we're going to go offline again. Now we're going to add a library that you can download from the Festo website. Actually, let's see where you can find that. It's an exercise. I'm going to open up the Festo website for you so you can see. Just 1 second. Here it is. It's loading. And then we're going to type in CPX-E-EC, which is the EtherCAT version of the remote I/O product that we're talking about today. And then we're going to click on support and downloads, and then we're going to go to well, expert knowledge. This is where you can download that application note that I showed you at the beginning. This one, that's where you can download it just by clicking on there. But if you go to software, there should be some function blocks here, unless it's under the here. I don't remember. Yeah, it's under here. Sorry. Let me download this so we can see. So I'm going to download this. Hold on. I'm going to download it into a folder. CPXE. 1 second. Bear with me. CPXE. Okay. So let's open that folder and then extract this that we just downloaded. Extract, yes, and then open it, and there it is. This is the library that I was talking about. So this is a library that you're going to bring into CODESYS in case that you didn't have it, and then there's your application note. Okay, so again, how to get to that? Just type in CPX-E-C, go to the support and downloads, go to expert knowledge, and then you'll find this application note. The library is actually zipped with that application note. Once you have that downloaded that, in case that you don't have the library already on the CODESYS environment, you can bring that library in by clicking on Tools and then Library Repository and just look for that file that you just downloaded. Alrighty, in my case, I already have it installed. So what I'm going to do is I'm gonna double click on Library Manager and then click on Add Library and then go to Application. I think this is in Festo AG, and then this is gonna be under Common. This is the one that I want. You gotta be careful about not confusing this one, CPX-E-EC, with this one. Under CPX-E-CEC. So there's another one here that's called CPX-E. Okay, I want you guys to use this one for this particular example, CPX-E-EC. Okay, so now we bring that library in, and then we go back to our PLC PRG. We can actually close that library manager, and we're going to create a couple of things here. So we're going to grab a box. Okay, just to recap, we want to read and write a parameter, right? So let's start with reading. First thing that we're gonna do is grab that box, and then we're going to click in here, and then we're going to call a function block from that library that we just imported, function blocks IO link, and we're going to grab the one that's called read parameter. Okay, enter, and then it's asking us to declare an instance of this function block. So I'm just gonna leave the default name for now. There it is. Now, the next thing that I gotta do is I gotta create I gotta declare a variable here. So I'm going to call this variable pby, or pointer of type byte, read data, and I hit enter, and it's automatically declared as type, and then click OK. Type pointer to byte, click OK. There's one thing here that's very, very important. You also have to declare, you have to address this to an array of data. So actually, let me declare it up here. I'm going to declare an array of byte that's going to be called array byte read data, and this is going to be an array, array of 0 to, this is the size, 0 to 236 of type byte. Okay, now this is very important because we're going to use this as a method to pull the data from that function block. So now we're going to say, okay, I want you to address this pointer to this array of byte read data, and I want you to start from 0, and that's it. Okay, so basically we're declaring this array of type byte, and then we're pointing this pointer to this array that we declare on top. And then the other thing that we need to do is we need to declare a variable where we're going to be transferring the data that we read. Okay, in this case, I'm going to call this UI for unsigned integer, read data test unsigned integer of type unsigned integer. Alrighty, so there we go. And let's also create another box down here to do some data conversion. And for that, we're going to go to module calls, CPX, the same library that we brought in. And then we're going to look for this converters folder. And then we're going to look for the one that's called byte array to uint, or unsigned integer. Enter. And then here we have to specify, okay, what's the data that you're going to convert and where to. So we're grabbing this data from that pointer and we are converting it to this guy, to the data that we wanna display or we wanna show, right? So that's it for reading. Let's see, online, log in, and let's do an online change. Actually, I have something wrong here. Oh, I'm missing. What am I missing here? Array by read data. What am I missing? A bracket. What is it saying? Cannot convert type byte to. I'm missing the addressing to that. Okay, let's give it another shot. Log in. I guess I should have compiled before trying to log in, but anyways. Okay, so now I don't have any errors. Now I can open this declaration of the function block, and now what? Now let's see what kind of parameter we want to read. So I'm going to go back to this user manual, and I'm going to go almost all the way towards the end of the user manual where we have, I think it's in the appendix, maybe. No, let me see. Oh, here. We're looking for the parameters. Here. So let's stay in page number 17 for the OBEM. I want to read the set point 1. Okay, and the OBEM that I have right now, it says that the default value for the set point 1, the default value ranges from 0 to -1 bar, where the raw data it's 0 to 16,383. And in my case, I believe I have a version H of the OBEM. Yes, mine is version H. So the default value is 11,468. Let's see, and this is it's equivalent to -0.7 bars. So let's see at the actual let's take a look at the actual hardware and see if that is true. If we click on the edit button, let me see here, edit, and then click edit again, edit. So that's the set point, -0.7, yeah, -0.700, and it's SP for set point that's flashing right now. So I'm going to edit that again so we can exit. Okay, so -0.700, which is the default value, right? So if that means that we should be reading a value, raw data of 11,468. So let's take a look and see if that is true. Let's go here. I'm going to put this side by side so you can see what I'm doing. Okay, I'm going to close this, and now we can kind of zoom in. So how do I read? Let's see here. Let's see. Let's make these smaller and smaller. There we go. How do I read? The couple of things that I need. Right now, this is saying the EtherCAT device address is 1001. How can I confirm this? If you double click on the EtherCAT field bus module, if you double click on that here, you can see the EtherCAT address and it's 1001. Imagine that I have 10 or 50 different devices. Each one is going to have an different EtherCAT address. So you got to know which one you want to read or write to or from, right? So that's right. I don't have to change this right now, but I do have to specify a couple more things. Module number. Which one is my module number for my IO-Link master, the one that I want to read from? It is starting from here. It is 1, 2, and 3. So it's module number 3, and I'm going to show it to you here in the hardware. So it is module 1. This doesn't count. This is 0. So 1, 2, and 3. This is my IO-Link master. Okay. So that's, now we know that that's going to be a number 3. I'm going to change this to 3. By the port, we are going to communicate to port number 0. Remember that we have 4 ports here, so 0, 1, 2, and 3. I'm going to communicate to this one right here, port 0. So we leave that at 0, and then index. Now, how do I determine the index? The index is specified here on the user manual. So it says it's a 3C hex. Usually, some people prefer to change this to hex, and now they can type everything in hex. You can do that, or you can also, for practice, you can always open your calculator, change it to programmer either by Alt-3 or clicking in here on programmer, and you can type in 3C, which is the one that we want, right? That's decimal 60. Okay, so let's change this to 60. And then subindex, it says that for the set point 1, the subindex is 0. So we're going to leave that at 0. And that's it. Right now, I just have to force these values, not force, but write these values into the actual values. So I usually use Control F7, but you can also click in debug and then go here, Control F7, and that's it. So now the only thing that I have missing is the execute bit. Right now this is at 0, right? We haven't read anything yet, but let's execute this function block, Control F7, and now we have a value of 11,468 right here. Meaning that, yes, I'm seeing what I showed you on the display, the minus 0.7 bars. This is equivalent to 11,468. Perfect. So that means that we are reading. And by the way, I'm getting a done bit here. So that's what you can use for handshaking whenever you put this into a sequence. So now I can say, okay, done. I can make this false and I can keep moving, right? What if there was an error? For example, oh, you know what? I made a mistake and I put in port number 2, which we know it's not enabled. Remember, this is the IO-Link port, right? I have 4 on that module. Port 2 is not enabled because we didn't enable it here on the, remember the startup parameters. So let's see what happens if I try to read from port 2. I execute, and then it's going to tell me, it's going to time out actually, I believe. So the timeout is 5 seconds. So there you go. Error, timeout. I can't read from that port. Okay, let's change this back again to 0 and try to read again. Done. 11,468. Okay, everything is good there. Awesome. So now let me make this bigger again so we can continue with our exercise. The next step here is now we want to write. We want to change this parameter, right? So I'm going to add another box. And as you can guess, this is going to be a similar thing. I'm going to go back here to function blocks. Here, 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 IO-Link, write parameter. Declare that function block. There we go. And then a similar thing as we did last time. Actually, I'm going to make some room here. I'm going to bring this maybe down here. So similar thing as we did last time, we have to declare this, which in this case, I'm going to call PBY write data. And this is going to be of type pointer to byte. That's perfect. The next thing, if you recall, is we had to manually create that array of byte write data. This is of type array with a size of 0 to 236 of type byte, right? And then the next thing that we have to do is marry these two variables by saying, okay, now I'm going to point this with this ADR or address to the ARR or array byte write data, starting from byte 0, close parenthesis, and that's it. What else do we need to do here? We also need to do what? Specify a variable that we can use to transfer whatever we want to write, right? So unsigned integer write data test. And this is going to be of type unsigned integer. There we go. All right, so the next thing is, as you can imagine, we also have to bring in a converter for the data type. Module calls, Festo, library, function block, IO-Link converters, and then now we got to look for the opposite from an unsigned int to a byte array. So scroll down, unsigned int to byte array. There we go. Now pay attention here because this is a little bit different. It's almost the same, but just a little bit different. Here we're going to have to link the data to this guy, right? But the value, it's this one, right? Remember? So now we have to type in here UI write data test. That's the variable that we're going to use. We're going to be using for writing. What can I do here to make it fit? There we go. Okay, looks good to me. Let's give it a shot. So if you recall, let me make this, switch this to the right. I'm going to hide this and hide this so we have some more room. And if we actually want to show this side by side, maybe what I can do is put one below the other one, like that. There we go. Make this smaller. Okay, now we have them side by side. Just to recap, before we continue, let's save in case of any catastrophes, log in and do an online change. There we go. Should be running there. Hide this again. All right. Let's just to make sure, let's read again and let's check. Well, the value is still there, but let's make sure that we still have connection. Control F7, true on the done bit, and the value is right there. Okay, 11,468, which is the default value. Let's rewrite or let's overwrite that value for something else. You need almost the same things that we established on the reading, the same parameters. You need actually almost the same things here. Module number, remember this is module number 3, right? Because it's 1, 2, and 3, right? It's the third module is the idling master. So module 3, port is 0, so we can leave that alone. The index, it was 60. This is the 3C in hex, and I still see it here, 60. The sub index is 0, so I don't have to change that. And right now, this is a common mistake. Right now, you might feel like, oh, okay, I'm good to go. But there's one parameter that you're missing here. It is the data length. This one right here, all the way on the bottom of the variables for this function block, all the way on the bottom, you'll see this unsigned integer data length. And what is this? You can see the length of this index. It says 2 bytes. So either you copy this value and you just type in 2 bytes there, Control F7, and now we have the 2 bytes there. And what if you forgot or something? Whenever you read here, I'm going to execute that read again. Whenever you read, it actually says the size of the parameter, and it says 4 for some reason. I don't know why. I don't know why. I guess I'm just going to use the same 4 to avoid any problems. So it says 4. I'm just going to use that 4. So let's scroll down and establish that 4. Actually, let's try the 2 because this is what it says on the user manual for the device. Let's try the 2 and see what it does. So we have where we're writing to, which index, which sub-index, what's the data length, and so on. Now we have to specify what's the data that we want to write, right? And for that, I was doing some conversions here earlier, and I want to write -3 bars because, you know, here it says -0.7. I want to go to -3 bars. What is that in raw data? I have this conversion here. So from the user manual, it says the maximum is 16,383, which is equivalent to -1 bar. The default is this. So you can say, okay, you can just do a conversion where you can say, okay, what I want is -0.3 bars, and you can just make a conversion there, multiplying this times this and dividing by this, and then you'll get this value. That's what I did here in my Excel formula, right? So 4915, 4,915 is what I want to write. So 4,915. Where do I write this? Remember that variable that we created, this write data test. So 4,915. Let's write that here, and now we can execute the function block. And let's see if it doesn't give us an error. You'll see it here. Control F7, and it is going to give us an error, apparently. Yes, timeout. Okay, so let's change that to this size, to 4, data length 4, Control F7, and execute again. Now it took it. So I guess the conclusion from that exercise is that just copy the one that you read. You're better off. It might be some conversion here that I'm not thinking about at this moment, but just for the sake of just finishing this exercise, just copy what you got from the read function block. So 4 is the length, and now it's saying, okay, I wrote what you told me to write, which was the value of 4,915. Let's see if that's true. Let's see if that changed. So let's go back to reading. Read parameter and make this true. 4,915. Now, if we go to the device, that should say, it was saying what? Minus 0.7 bars earlier, right? So let's check it out. Let's see if it changed. If I click the edit button, spec, okay, click on that again. That's the set point. It's minus 0.3, what I specified now. So this is one of the beauties of IO-Link, that you can remotely change these parameters, right? And as you can imagine, you can just create a sequence and just push the parameters down to the device. So it went from minus 0.7 to minus 0.3, which is what we wanted to do. So that's how you do it in this case. Of course, there are different approaches. This is with CODESYS, but you can also do it with a Rockwell PLC or with a Siemens PLC. It is possible. I just wanted to show you the principle of the index, sub-index, and some of the other variables that you have to declare. In the case of CODESYS, I mean, now you have a good example here that you can use for future reference. Anyways, I think I covered everything that I wanted for today's video. Hopefully you liked it, and now you know how to change parameters of an IO-Link device using a CODESYS controller over EtherCAT. Thank you for watching.